All right, for this one, they want us to find the Taylor series for sine of x centered at pi over 2. So let's start again with our finding our derivatives here. So n equals 0 would just be our original function. So that would just be sine x. And if we find that at our value now of pi over 2, let's see what we get. So if you did sine pi over 2, that's at 90 degrees. Our y value at 90 degrees is going to be 1. You can check that with the calculator too. All right, now let's find our first derivative of this. So first derivative of sine x would be cosine x. Cosine x at pi over 2 would be the x value at 90 degrees, which would be 0. Our second derivative would be negative sine. Evaluated at pi over 2 would be negative 1. Let's do the third derivative. Derivative of negative sine would be negative cosine. At pi over 2 is going to be 0. And let's do one more. Fourth derivative, derivative of negative cosine would be positive sine. We've had that one before. That should be 1. All right. So now if we want to fill in our Taylor series expansion here, starting at n equals 0, going to infinity, it's going to be our value here at pi over 2 all over n factorial, and then here, because it's centered at pi over 2, it'd be x minus pi over 2 to the n. So that would be our approximation here of sine x at pi over 2. If we want to fill in some of these values, let's look at the first, what these first 4 terms would be here. So that would equal, if we put 0 in, we're going to get our value that we see here at 0 would be 1, our function at there, over 0 factorial, which is also 1. And then we'd have x minus pi over 2 to the 0 power, which is also 1. So this first term is just going to be 1. Next one. So now we're putting the next value in, which should be 0. And this one, it's not going to really matter what this other stuff is, because 0 times anything is going to be 0. All right, let's go to our next one. So now we have our next coefficient value, negative 1 over 2 factorial, and this would be x minus pi over 2 squared. So that should evaluate to negative x minus pi over 2 squared, and 2 factorial would be over 2. All right, our next one here would be, looks like also is going to be 0 here. That was our value we had gotten over 3 factorial, x minus pi over 2 to the third. So this is all just going to simplify to be 0. Let's do our last one here. So if we did 4, the value was 1 over 4 factorial. And then this would be x minus pi over 2 to the 4th power, and this should continue here just like this would continue. Let's take out the terms we don't need there, so it would end up being 1 minus x minus pi over 2 squared over 2, or that was also, if we wanted, we could keep it as 2 factorial there. The 0 one we don't need, so this would be plus. The next one would be x minus pi over 2 to the 4th power over 4 factorial. And I think if we keep going with that pattern, the next one would be 0. And it looks like it's alternating here, so the next one would be x minus pi over 2 to the 6th power over 6 factorial, and keep going alternating. So what would, let's see if we could write this one out as a simplified series here. So what would it be as a simplified series? Can we come up with anything? Well, we can see that it's alternating. It switches between positive and negative terms here. So it's negative. There's going to be a -1 in there. We want the first one positive, so I think if we just go with plain old n there, that should work. All of these have a x minus pi over 2 to some power. It's just that the first power is 0, but we only see the even ones. There's no odd powers in here. So we could accomplish that by making this a 2n, because then it's just going to come out to be the even one. So if it's 0, it's 0. If we put 1 in there, it'd be the squared one. If we put 2 in, it'd be 4. If we put 3 in, it'd be 6, and so on. And then same thing with the factorial. It's only the even one, so we could go 2n factorial. So there would be the series for sine of x centered at pi over 2. Okay. If you wanted, or we wanted to show what the radius of convergence would be for this one, we could do that by using our ratio test. So if we do the ratio test, we do the limit as n goes to infinity here of our term plus 1 over our term here, the absolute value. And we do absolute value, that way we don't have to worry about that alternating part that we had in this one, because it is alternating here. Because that'll just, if we do absolute value, this would just be +1 no matter what. So let's see what we get here. So it'd be limit, so n goes to infinity. If we did our n plus 1 here, this is going to be x minus pi over 2. This would be 2 to the n plus 1 over 2 to the n plus 1 factorial, all over our original one, meaning it would be all over what we see up there without that alternating part. All right, so I'm going to multiply by the reciprocal, and we'll do some simplifying here. So oops, let me get my limit notation in there. Oh, should be n. So this would be if we do some distributing here and distributing here, this is going to be x minus pi over 2 to the 2n plus 2. On the bottom, we're going to have 2n plus 2 factorial. I'm also going to multiply by reciprocal here, so we'd end up with a 2n factorial up here, and on bottom we'd end up with x minus pi over 2 to the 2n. All right, so let's use some of our algebra tricks here to evaluate this limit now. So we can make this exponential up here. Another way we could write that, if it's two things added, is we could do it as x minus pi over 2 to the 2n times x minus pi over 2 to the 2, because if you have the same base number and you put it together, you add the exponents. On the bottom here, let's expand this factorial out. So the term less, that one less than this would be 2n plus 1. The term less than that would be 2n, and then it would continue on with that factorial. So now we can cancel some stuff out here. These two should cancel. Also, the factorials cancel. So what's the limit of the rest of this stuff as we go to infinity here? Well, if you were to multiply those terms out in the denominator, what we're going to get here is that this would be 4n squared plus 6n plus 2. And if we're going, as n goes to infinity, this is going to get very large. That's going to go to infinity. But if it's on the bottom, that means if we got large number on top over a larger number on bottom, this is going to go to, this whole thing's going to go to 0 here. So since it's going to 0, which we're looking at, and that's less than 1 for our ratio test, this one is going to be convergent no matter what. So it's convergent for all x. Our choice for x isn't going to matter because this is going to 0 no matter what. So that would mean the radius of convergence for this one would be all numbers, or we could say that it's from negative infinity to, or the interval of convergence. Interval of convergence would be from negative for all numbers, and the radius would be all, or infinity or all numbers.